Welcome back to the course. In this lecture, we will talk about sector coupling. The learning objectives for today are to introduce the concept of sector coupling. You will learn why this is important and what it means in practice. But first, I'm going to explain what the different sectors entail. The idea of sector coupling from an energy perspective means that we're going to link the energy production and energy consumption of different sectors. A sector represents a specific group of energy users. For instance, we can identify the residential sector. This consists of living and working. We also have the transport sector, where people commute and people travel. We have the industrial sector, where things are produced. Here products are created and services are being offered. And we may link all these sectors and their energy consumption needs with the power sector, where energy is being produced. What is sector coupling? The definition is that sector coupling refers to the interconnection or integration of different sectors of energy consumption. For instance, the building sector for heating and cooling, the transport sector and industry are integrated with the sector where the energy is being produced. Sector coupling has several advantages. First of all, it allows for more flexibility of energy use. The different sectors have different demand profiles. This can provide additional flexibility in matching supply and demand. It also allows complementing energy resources over different sectors. For instance, in the industry sector, residual waste heat from the industry can be used in the residential sector for space heating. This allows for better resources optimization. By making use of all available resources, the overall energy efficiency can be increased. Sector coupling will become very important in the future when the share of renewable energy further increases. When the share of renewable energy is limited, it can be used for exchanging fossil fuels without too many problems. For an increased share of renewables, we also need to adapt our energy infrastructure. But for implementing large-scale renewable energy in our energy system, we require sector coupling in order to deal with the variability of renewable energies. Problems will arise when solar generation is low or wind generation is low, but consumption is still high. Now, sector coupling may help to increase the efficiency of the energy system and to allocate energy in an optimal way. Sector coupling has different aspects. It has a technological aspect, but also a geographical aspect. I would first like to discuss the geographical aspect. Certain regions have a preference for a certain technology. Most notably is the preference for renewable resources based on their local availability. For instance, wind production is optimal in the northwest of Europe, in the UK, the Netherlands, Norway. These countries have the opportunity to use the North Sea and parts of the Atlantic Ocean where there is a high availability of wind. So this is a good location for wind farms. The southern part of Europe is more suited for solar energy. In these countries, the solar irradiation is higher. It makes sense to invest in solar energy in those countries. By coupling wind generation in the northwest of Europe and solar generation in the south, we can try to cover the demand for energy in Europe. But for this, we need to be able to transport energy from one side of Europe to the other side when needed. This can also be combined with other energy resources like the availability of hydro energy in mountainous regions. So this slide illustrates some of the geographical variations of renewable energy resources. By coupling these regions, the impact of seasonal fluctuations on the availability of energy can be partly mitigated. There's also a technical component to sector coupling. Sometimes there is a need to change the energy carrier between sectors. For instance, on the right we have the residential sector and the industry which need heat for space heating and industrial processes. For generating heat, we need an energy source. Nowadays, this is typically provided by burning coal or natural gas. But it can also be provided by converting electricity to heat. Electricity can be generated in wind and solar farms located all over Europe. Electricity of solar power can also be used as an energy source for the mobility sector. Previously, cars were fueled by gasoline and diesel, but presently the European Commission promotes the use of electric vehicles. For this, we need to couple the electricity production sector with the mobility sector. It is also possible to store energy in gas or liquid fuels like hydrogen and use this gas or these liquid fuels in cars. So, by conversion of renewable electricity to other energy carriers, like hydrogen or chemical energy in batteries, we can use renewable energy for other purposes. This is another example of sector coupling. In this slide, the interactions between the different infrastructures are sketched. 3 energy infrastructures: the gas infrastructure, the heat infrastructure for district heating, and the electricity infrastructure. By investing in efficient conversion between these energy carriers, we can use the energy in one infrastructure and, after conversion, apply it in another infrastructure. Sector coupling becomes even more interesting when we add storage to the different infrastructures. Gas storage in empty gas fields or in the form of liquid natural gas, electricity storage in the form of batteries and pumped up hydro, and heat storage in the form of heated fuels in tanks. Now we can use the storage capacity of one infrastructure to optimize the energy use in another infrastructure. There are, however, several requirements for making this work. One requirement is an efficient conversion from one energy carrier to another. We also need to have sufficient storage facilities, which do not have too high losses. And we need to have intelligence added to this system. This means that we need a smart energy grid in which the conversion of one energy carrier to the other is optimized. In this way, the demand profiles of gas, heat and electricity can be more efficiently matched with the overall energy production profile. For efficient sector coupling, we therefore need intelligence added to the energy system. We need smart design and smart operation techniques. The required technologies are in the process of being developed. It allows increasing the efficiency of the overall energy system. Smart infrastructure is necessary for having an efficient conversion between energy carriers. And smart buildings are required for adapting the consumption of energy to the availability of energy sources. For this, we need demand response, which means the possibility to adapt or delay energy consumption. And we need smart mobility. This entails knowledge of consumers when is the best moment to charge your electric car. All these aspects will be elaborated later during the course.